Hello and welcome to part 2 of this little 5-minute short series all around pumps and how we look at pumps, design pumps within PEL. So part 1, we looked at this little sketch here and we did just for one single flow rate. We looked at the pressure drop through here, the pressure drop through here. We thought about our static head and liquid levels, and we came up with a little delta P across the pump, so what that pump would need to do for a certain flow rate. Now, when we get to the real world, what we'd actually want to do is develop a system curve. We want to know what that looks like with different flow rates. So that's what we got on here. So click on this little tab here, it says system curve. And this looks a little bit messy. I apologize for the messiness, but I've done this a couple of ways just to sort of show what we're doing and how this works. And we're going to show you a little bit of the, I suppose, the functionality of Excel, which is what's so nice about having Capri in Excel. So we're trying to look at how the delta P across that pump is going to change with flow rate. So what I've done here to start off with, making it sort of very sort of simplistically, I've again modeled that inlet side, I've modeled that discharge side, and I've done exactly the same calculation down here. So I'm looking at the liquid levels, pressure losses, getting that pressure at the pump suction, pressure at discharge point to get a delta P across the pump. So I've built that little bit in this sheet. Now, this bit here, what I've done here is I've actually inserted an equation, one of the Capri equations. So how would I know to do that? If I go to my incompressible flow sheet and I click on help here, I'll do help on current calculation. And I can look down here and I've got something called PEL, incompressible flow. This one, pressure drop. Now the trick is underscores under there, you can't see them because it's underlined it as a hyperlink, but it's PEL underscore incompressible flow. So if we squidge that out the way, if I go to my system curve, I can then go to here, insert function. So in search, let me just start again. We could do PEL underscore, healthy spell PEL at, underscore incompressible flow. And then what we're after is that pressure drop one. Now I press OK, it's going to produce exactly what we've produced there. So I've obviously linked these to the other sheets. If I change things, it'll all filter through. But the one I'm really looking at is, and the interesting bit is this little equation here. So that's giving us that pressure drop, given all those inputs, given all those units. So what we've got here, one is to develop a table. We want to develop a table of flow and then pressure. And there's different ways of doing it, but the way I've done it in this way is done different steps. So I've got different steps I can change these if I wanted to do whatever it might be, because I quite like the function of doing that. And then I want to develop that pressure. Now I could just take this equation here. I could start pressing F4. You can see I've started doing it a little bit in here and locking some of these down, whatever it might be. Gets quite burdensome doing that kind of stuff. So I've used a little technique that's built into Excel. So if we show you on this little table here, I've got this flow rate here. So they're just the numbers that I'm picking. And what I've done here, this pressure drop, which is what we're looking at, delta P across our pump. I've just linked it to this value because this is what's going to do the calculations. So what basically Excel is going to do is going to change one variable and it's going to pick up the value from there and just do it for all our data points. So I'm going to select this little bit here. Let's go to data. I'm going to go to a data table. So this is a column. So I've got a column input cell. So I'm changing my mass flow rate and I've made that one equal to that. So as I change this, or as the computer changes this, it changes that. Both those values will change and the answers will appear here. And that's what it's going to pick in these columns here. So if you're not quite sure about that, online there's lots of help with that. But it's just using a little data table. And then I can press OK, and you can see it's filled those numbers in. And you can see it's got table, it's picking up. So again, if we changed anything up here, this would change automatically. So that's how this table has been produced. And I've got a little table of flow rate versus pressure. I then need to make that into volumetric flows or system curves. When you look at volumetric flows, that's quite simple. Now using the density, see I'm just picking up the density value there and the flow rate, that's going to be as cubed. And then for the head, again, you could use simplistic equations for doing that and convert it into meters. But again, there's a little equation in Capri. So head from pressure. Again, if I go to formulas, I can look in there. So you can see there is what are my units? I've picked up meters. Pressure loss, in this case, is that value there in bar. And then I've picked up the density and the density of units. So these could be any sort of mix and match of units. And it gives me the head loss, saves me making mistakes and typing that equation in. So I can then develop a flow rate versus head loss. And if I look at that, then you can graph that and you can start to see that system curve. And you see we've already got a pump curve on there, and how we generate that pump curve we'll look at in the next couple of shorts. Another way of doing this, maybe a slightly simpler way of creating your system curve, is we can just use that equation once. So again, I've got that incompressible flow pressure drop. And what I've done here is I've put all the pipe work into one equation. So instead of having 3 meters and 10 meters, I've got 13 meters. I've got a K value of 18, adding it all together. So what that is doing with my flow rate is it's producing a delta P across all the pipe work of just over a bar. And then what you need to think about is, well, what's the pressure differentials in those two vessels? Well, I've got them both at atmospheric pressure, so there is no difference in the pressure. The static head, so if I go back to my sketch, and this is where I am going to include this extra meter. So I've got this 2 meters here and the meter here. So this is at 3 meters above datum. This is at 5 meters. So the difference in static head is 2 meters, which is what we got there. That's that pressure differential. And you can see it's created that system pressure. And then I've done exactly the same here with a data table. So this time I've made that the cell is calculating. Again, I'll be doing it via columns, changing the mass flow, and it produces the same table. But then that will then give me that system curve, and then we can, in the next 5-minute short, look at how we do the pump curve and then start to bring some of this together. So hopefully that was useful, and I'll see you next time for part 3.